Climate Change and the Effects of Hurricanes by Carson Dunyan and Jack Lissy. Uh, Climate change is the change in atmosphere over a long or short period of time. The climate change that is happening currently is short term and is caused by an increase of greenhouse gases in the atmosphere. As stated by Geophysical Fluid Dynamics Laboratory, a research team uh, fundamentally linked with the understanding of the physical, dynamical, and chemical processes governing the behavior of the atmosphere, oceans, land, and ice, say tropical cyclones intensities globally will likely increase on an average by 1 to 10% based on a 2 degrees Fahrenheit global warming. This can do extra damage to buildings, the ecosystem by depositing tons of water onto them, uh, and the economy by destroying homes and businesses. This happens when heavy rains cause flooding in inland places, high winds knock over trees and other tall buildings, and storm surge pushes seawater onto the land. The problem is coastline cities aren't prepared to deal with the effects of a hurricane. As shown by the graph to the left, hurricanes have caused over 8,000 deaths and $600 billion in damage. Nearly all houses in a hurricane are completely destroyed and have to be built anew. This is furthered by the damage to the economy, having to repair houses and shops and buildings and having no income in the area. The problem there, the electrical grid is also damaged, as quote, the average storm would reduce log nightlight intensity by 1.5%, whereas 15 months after Hurricane George, the log nightlight intensity was still reduced by 21%. This shows how long the impact of power loss of a hurricane is. This is not helped by the fact that these types of storms are increasing. According to the GFDL, tropical cyclones rainfall rates will likely increase in the future due to anthropogenic warming and accompanying increase in atmospheric moisture.
The first solution that could be used is to reinforce housing and buildings. In 2018, Hurricane Michael hit Mexico Beach, Florida. One house took little to no damage, while every other house around it was completely destroyed. Quote, but it didn't, when the New York Times published an analysis of aerial images showing a mile-long stretch of Mexico Beach, or at least 3/4 of the buildings were damaged. Dr. Lackey saw his sand palace still standing, majestic amid the apocalyptic wreckage, the last surviving beach house front on his block, end quote. The New York Times. The house survived Hurricane Michael along Mexico Beach. But how did it survive? First, the house was elevated with 40-foot deep pilings, which allowed the building to stay extremely sturdy. It also had reinforced windows so that high winds couldn't get into the house. Here are all the modifications that were made to survive hurricanes. The walls are poured of reinforced concrete. The house sits atop pilings that are 40 feet deep. Steel cables travel from the girders above the pilings through the roof and continue down the back wall. A proposed balcony on the east wall was removed at the design stage. The roof overhang was kept very small compared with adjacent properties. Some proposed windows were replaced with concrete, and the house is raised on stilts that the storm surge could pass underneath. Next slide, please. Pilings are even used in important buildings, such as the New World Trade Center. Quote, 10,000 workers attempting one of the most complicated construction projects ever in one of the most densely populated places on the planet. Design almost entirely called for a 104-story tower that includes a bomb-resistant 20-story base, some 70-ton shafts of steel, and pilings sunk some 200 feet into the earth. The unseen subterranean structure would support 48,000 tons of steel, the equivalent of 22,500 full-size cars. However, this house design is expensive and wait, next slide, please. However, house design is expensive and people in lower income areas by the coast won't be able to afford it. The design is also elevated off the ground, which might make it difficult for disabled people to go up and down the house, since it is elevated off the ground. The houses will take a long time to make because you have to have the 40-foot deep pilings and the stilts to support the building. It also may hurt the environment because of all the current houses having to be knocked down. The major drawback is having to build each new housing unit. The residents of those homes aren't going to have a place to live and may have to stay somewhere else until their new houses are built. Next slide, please.
Yeah, Carson, your mic's off, so you got to go back to the start. There you go.
Thank you. Sorry.
No worries.
The second solution we have is to stop the hurricane before it is even formed. According to National Geographic, the sea surface temperature must reach at least 80 degrees Fahrenheit to birth a Category 4 or 5 storm. This means that if the surface water was cooled down, there could be a mitigation of storm damages, as a hurricane category directly correlates to damage. There are a couple ways to go about doing this. One way is a bubble curtain, a series of perforated pipes that use compressed air to create bubbles that disrupt the surface of the water. This solution is backed by Ove Hollingster, a former Norwegian naval submarine officer that is trying to make this a reality. She explains it would target a weaker tropical storm before it has the chance to intensify into a true hurricane. Another way is to first force colder water onto the surface. Stephen Salter wants to make this a solution by putting long tubes that are like drain pipes coming down from enormous floating rings. They then reach down into cold water, and as waves go over the rings, the water level inside would rise and deposit the cold water on the sea surface. Although the bubble curtains are used currently, they have never been used to stop a tropical storm, and thus is hypothetical. Also, any hypothetical parts has drawbacks like the sinks that would drift more through a stormy sea. Also, if they put into practice cooling a big enough swath of ocean to suppress a hurricane, it could put rainfall at a risk in distant drought-prone regions or upend the environment in some other way. However, the solution would be able to stop a storm in its tracks, and it could have some secondary secondary advantages, like preventing noise from other machines.
Solution 1 is better because it has actually been put into practice. While the damage is still done, secondary damage is minimized thanks to less people losing power. Also, the solution is made to last so that the houses can stand through many hurricanes while only taking minimal damage. Quote, concrete piles can be used to support large loads, are resistant to decay and boring organisms, and have little or no impact to water quality once hardened, and it has relatively high compressive strength, end quote. California Coastal Non-Point Source Program. This proves the effectiveness of pilings, but the solution has its drawbacks via the houses having to be rebuilt, which can leave people with having nowhere to stay and can hurt the environment. The solution is more realistic and has already been put into use, unlike solution 2. Another problem with solution 2 is that if the rig malfunctioned and collapsed, it could damage the ecosystem drastically. Solution 2 will also be very expensive, but so will reinforcing every house that could possibly be hit by a hurricane. Next slide, please. And thanks for listening.
Terrific. Okay, guys, I got a couple of questions for you. The first one for Carson, describe an argument from Jack's individual report that made you think differently about your conclusion? You guys concluded that like rebuilding the houses were better. How did Jack's report influence that decision to include that conclusion?
So with Jack's research, he actually found out about the he found out about this house that was the only one not destroyed by a hurricane in his neighborhood, I believe. And I thought that was a something that we really have to look into as a possible solution. And luckily, Jack did a lot of did some preliminary research on that as well. So he so he both he made an entire he researched pre-researched an entire solution that we had, the conclusion that we had, because
Terrific. And then Jack, as a follow-up, and this is a great question for your group in particular, if you had another team member, right, what perspective, limitation, lens could they have examined that might have helped you guys round out this problem of hurricanes?
They, if we had another group member, I feel like the economic side would be really good, because we didn't really go in depth about the costs of each of these two solutions, because they're both very expensive, and I feel like we could have looked into it more, so that it would be more rounded out, and we could like decipher all everything, so that we know all of the benefits and all the drawbacks.
Terrific. Thanks.